So can we start?
Please.
Okay. So good afternoon to all of you. So we assemble here again for the overall 8th session of this FDP and second session of today's. So we have with us Professor Dhananjay V. Gadre sir from Netaji Subhas University of Technology for giving a lecture on leaf node design guidelines for implementation of IoT. So I would just like to give a brief introduction of sir. Dhananjay V. Gadre sir is currently working as Associate Professor in Electronics and Communication Engineering Division at Netaji Subhas University of Technology. Sir has completed his MSc in Electronic Science from the University of Delhi and ME in Computer Engineering from the University of Idaho, USA. In his professional career of more than 25 years, Sir has taught at the SGTV Khalsa College, University of Delhi, worked as a scientific officer at the Inter-University Center for Astronomy and Astrophysics, Pune, and since 2001 has been with the Electronics and Communication Engineering Division, Netaji Subhas Institute of Technology, New Delhi, currently as an associate professor. He directs 2 open access laboratories at NSUT, namely Center for Electronics Design and Technology, CEDT, and TI, Center for Embedded Product Design, TI CEPD. Professor Gadre is the author of several professional articles and 5 books. One of his books has been translated into Chinese and another one into Greek. His recent book, Tiny AVR Microcontroller Projects for the Evil Genius, published by McGraw-Hill International, consists of more than 30 hands-on projects and has been translated into Chinese and Russian. He's a licensed radio amateur with a call sign BU2NOX and hopes to design and build an amateur radio satellite someday. So we welcome you, sir, in our FDP.
Thank you, Naman. Thank you for your warm welcome and good afternoon to all the participants. These are very interesting, I would not say interesting times. These are challenging times, and I hope all of you are facing this challenge head on. Stay at home and maintain physical distancing. When they say social distancing, I don't like the word social distancing. Social distancing means you're not even talking to people. I think what they meant was physical distancing. Keep physical distancing, remain socially connected as close to others as possible, and wash your hands and all that. I hope you are all following it. Yesterday, I had a little bit of scare. I had a little bit of fever last night, but then I figured that I also had an upset stomach. So my doctor in the college said, no, it is because of the upset stomach. I had a paracetamol. I started a, dose of antibiotics for the upset stomach. Now I am perfectly fine. Otherwise, I was going to request Naman to excuse me for this lecture, but it seems everything is fine. It is nothing to do with corona. Any fever that you get these days, you suddenly feel, oh, it's corona. So I think corona has sort of invaded our minds and brains and everything around us. I think we need to fight that fear more than anything else. Anyway, so I hope you all are having a good time trying to understand various aspects related to Internet of Things. I am going to show you some guidelines of designing the leaf node. And leaf node, as you know, you can think of IoT as a connected tree, and this leaf node is the end element, like a leaf in a tree. And it is actually also the source of all information. That in the IoT design, the leaf node is actually the source of information, and that is stored and processed in the cloud and so on and so forth. So it's very important to understand what are the elements of a leaf node, how to design it in an efficient manner. And at the end of it, or even before, you know, you probably have got an idea that leaf node of a IoT is nothing but a specialized case of embedded system, where all the elements of embedded systems are taken into consideration with an added uh, component, which is to connect the internet. Also, what has happened in the past few years is that several related topics have come into popular discussion. The most common is called physical computing. Physical computing means a computing device which is aware of the physical environment. And then the second topic, which is second, title which has become popular, is cyber physical system. So as the three words indicate, cyber, physical, and system. So cyber means there is it's a distributed across the network. Physical means that it is physically aware. It has sensors and actuators, and it's a system. So it's like a multi-processor system distributed across the globe, connected through internet. But that is what it distinguishes it from IoT. IoT also is like that, but IoT necessarily the interconnection between the various elements of IoT, the interconnection is through internet. Internet, as you know, is a open source, public resource, where you can have a private resource. You can have a satellite communication, you can have fiber communication, which nobody else can access. In a cyber physical system, because of the requirements, you would opt out for, you would not use internet, and you can use your own custom communication protocol, and that converts a IoT into a cyber physical system. And then at the end, we have the embedded system, which has all the elements, except there is no necessity that there should be internet or there should be any sort of communication with the outside world. So these are all four related topics. I could show you a, let me see if I could show you a diagram which interrelates uh, these four topics. Let me show you. Are you able to see this diagram, Naman?
Sir, right now your PPT, yeah, now it is visible, sir.
Okay, so you see there are four circles. It's like a Venn diagram of these four topics, which are very closely related. At the end, in the center is the Internet of Things. And then outside that, in the overlapping, this thing is the embedded system and a cyber physical system. And then the overall, everything inside is enclosed within what we call as a physical computing system. So this might be a useful diagram. I will also incorporate it in my, this is part of a book that I'm writing, so it is not yet in my PPT. Maybe I should incorporate this so that it gives a perspective as to where is IoT in the general scheme of things related to cyber physical system and embedded systems and physical computing. Anyway, so let me go back to my presentation. I'm going to talk about the leaf node design. There is no need to repeat this about Internet of Things. You already are aware that it was a term coined by Kevin Ashton in the context of supply chain management. And the core idea is very simple. Anything that you can connect, you should connect to the internet and let them talk to each other and let them exchange information. That was the basic premise and basic motivation for Internet of Things. Now, the internet, the IoT nodes.
Sir, I think there may be some problem. So your screen has been stopped, I think. Yeah, it's visible now, sir.
Now, so these are various shades of the IoT nodes. Let me show this in the perspective of IoT so that you are able to. Is this diagram visible?
Yes, sir. Yes, sir.
So you see there are these nodes. You have the cloud storage, cloud computing, and then through internet you have the users which are connected, which can do data visualization and analytics and all that. Do you see this diagram, Naman?
It is visible, sir.
ठीक है. So here
Sir, I think there is some bandwidth problem. You can turn off your camera.
अच्छा.
So हाँ तो सर शायद PPT फिर सही से चले, शायद थोड़ा bandwidth problem हो रही है सर.
हाँ हो सकता है. अभी मेरी आवाज ठीक से आ रही है?
हाँ हाँ जी सर.
ठीक है. I have shared the screen.
हाँ सर अभी शो हो रही है सर.
So these are the three implementations. The important points from the leaf node point of view are three elements. One is called the sensor node, the actual sensors and ADC and microcontroller, whatever may be required. Now, this information can be as it is put on the internet, but I have put an element called data reduction and then internet gateway. Internet gateway is that channel through which your device can connect to the internet. And then there is a second model in which the sensor node and data reduction unit are integrated, and several of these are sharing a common internet gateway. And then the third is the sensor nodes are distributed and they are sharing data reduction and internet gateway. Now, what is this data reduction unit? So data reduction unit is a computational device which would extract useful data out of the sensor information. I can give a very interesting example. Let us say that your IoT system is measuring, counting, or keeping a record of all the vehicles that come into a campus. Right now, the sensor information, the sensor node would consist of a small camera, which would be positioned at the height, typical height of a vehicle, the number plate. It will take a image, and then it can just upload this information to the internet through the internet gateway to the cloud, and the cloud program can extract information out of it. This is one way of doing it. Now, if you do it, the problem is that a huge amount of useless information regarding the image would also be uploaded. You only want to know the registration number of the vehicle, but you are sending an entire image. And this will. Hello?
Yes sir, you are audible sir.
हाँ एकदम वो स्क्रीन में से कुछ चला गया तो मुझे लगा.
हाँ जी जी सर.
So if you only want to send a few bytes, which is related to the car registration or vehicle registration number. But without the data reduction unit, it will be impossible. So what does the data reduction unit in this case do? It will do a digital image processing of this image and extract only the number plate information. And this way, the amount of data that is sent on the internet can be reduced from hundreds of kilobytes, a typical image, to a few bytes. And this will make for a very efficient system. Of course, the efficiency that you gain in terms of the internet connectivity, some efficiency will be lost because now you have another computational unit which is implementing the digital image processing program. It will also consume some power, but here you are saving bandwidth and you are spending some extra energy in the computational requirements. And so whether you should have these IoT node of type 1 where the sensor node, data reduction, internet gateway are all bundled into a single device, or the internet gateway is shared, or the internet gateway plus data reduction unit is shared across all the sensor nodes, will depend on a typical topology, on your particular topology of your IoT. You as a designer will have to make that choice. Now, we also must look at what are the characteristics of the sensor node. So in the next slide, that is what I'm talking about. So you have the leaf node parameters and the sensor characteristics. Subcategory is what is human information, or is it a physical entity in the form of temperature, pressure, humidity, etc. Then this parameter, what is the acquisition rate? Is it being continuously acquired, or is it infrequent? And or is it on demand? That is, some event happens when the threshold is exceeded, then you send the information. So you have to estimate that. And then what is the trigger? Is it a time triggered, or is it a system state, or is it a physical event? Something happens, then only information is sent. Then the second part is what is the computational requirement of this sensor characteristics. The computational requirement will depend on what is the bandwidth of the sensor information. Because if your sensor information has a bandwidth of say 10 kilohertz, then you will have to sample it at least 20 kilohertz, the sampling rate, and then you can extract useful information out of it. And typically the range can go from less than few kilohertz or less than kilohertz to hundreds of megahertz, depending upon what is the type of the sensor. And then you have to look at what is the physical size. And again, size can be from less than a millimeter cube to tens of centimeters. What is the source of energy? And it has two aspects: the actual source and then the lifetime of the source. Because the lifetime is very important. You can say, oh, I am going to use a say lithium battery. Hello, am I audible, Naman?
Yes, sir. You are audible, sir.
So if your source is a battery which is lithium, lithium is one of the most efficient batteries, but the lifetime of a lithium battery is 3-4 years. And so if you are sending a probe, outer space probe, that is going to last for 10 years, then the lithium battery will be useless, right? So that is the meaning of lifetime. You have to find out for how long the source of source of energy has to last. The source itself can be wired, that is, it is connected to say a wall source to 20 volts or 110 volts, or it could be battery, or it could be a scavenged source, meaning some RF energy is available or some vibration energy is available, and you convert from that energy into electrical energy. And then the lifetime, is it few hours, few days, few years? All that you must consider when you are designing the leaf node. And then last but not the least, because communication is an important aspect, how are you going to implement the communication? Is it wired or wireless? What is the data rate and size? When you send a packet of information, is it few bytes or few megabytes? Data rate, is it in kilobytes or megabytes? And the interval of communication, is it continuous or infrequent? Is it event triggered or system state trigger, and things like that. Important characteristics have to be considered when you are designing a leaf node. Now, as we see that all the aspects of a leaf node are, are very common, shared with the elements of embedded system design. So here I am presenting you an interesting diagram that we have developed, which we call as a 6-box model for designing embedded systems. So what we can say now is that IoT leaf node is a special case of embedded system. And as you see here, we will I will illustrate that all the elements that you require, all the components that you require for a IoT leaf node, they are present here in this model also, which is the model for a embedded system design. We think that there are 6 boxes, and these 6 boxes completely describe any embedded system application that you can think of. The most important.
So there is some, I think, connection is network issue. So now screen is visible, sir. No.
Yeah. Am I audible now?
Yes, sir. Yes, sir.
Okay.
You.
So we were talking of, we were talking of the 6-box model. The important, in fact, all the elements are important. All the boxes are important. The first box in this series of boxes is the input devices, which may be the sensors or human interaction devices like switches and things like that. The information from these devices are passed on to a controller. The controller is your embedded controller, which is going to process this information, and based on the algorithm and the program that is programmed in it, it is going to produce an output, and the output will be sent to the output devices. It may be local, or in the case of IoT, it could also be through communication and network, the block number 4. It may also be storing or processing that information locally. So we have another block called host, and all of this will require a power supply for operation. As we mentioned, is it battery or is it a wired source? And all of it also requires some electronic glue. Electronic glue is some analog or power switching kind of a circuitry which will be required to connect the input devices to controller. For example, suppose your input device is a sensor which is producing very noisy and very low amplitude signal. So you will need to amplify it, and you will need to filter it so that you can then convert it or connect it to the microcontroller, which may have a on-chip ADC, to convert it into digital information. So this analog circuitry of filtering and amplification will, in this case, comprise of the electronic glue that I mentioned here. So using this model, you can describe any and every embedded system design that you wish to undertake. Then the input box that we mentioned, these are the type of inputs that you may require. User inputs in the form of push buttons, toggle switches, selector switches. Sound can be an input in the form of microphone using a sensor called microphone, or ultrasonic inputs. You would like to have be able to measure magnetic field, and that you do that with the help of a Hall effect sensor or an inductor or a reed switch or even a magnetometer. You may want to input information related to distance, which can be measured using ultrasonic ranger or IR proximity sensor. Similarly, temperature is very useful parameter. It is often required not only for independent measurement, but also for compensating some other parameter that we may be measuring, because many of the parameters are temperature dependent. So you may want to compensate that using a sensor. And these various sensors, thermistor, RTD, thermocouple, semiconductor sensors are used. Then light is a important input parameter. You could use a LDR or a photodiode. Interestingly, even LED can act as a sensor. You could use that. And then you have strain and force for in audible now?
Yes, sir. Yes, sir.
So strain and force relative position, you can use a shaft encoder, you could use a gyroscope or an optocoupler, linear potentiometer, or a global positioning system can be used for position. Then image is a very important input parameter. You could use a CMOS camera, or you can use linear CCD arrays. And then time is one of the most important input parameters. For that, you can have a real-time clock, or you can maintain relative time using a clock and a counter within the microcontroller or the embedded computer. So these are various illustrative input parameters. These are various output parameters. You may want to output light through LEDs, RGB LEDs, laser or infrared LEDs. You may want to output visual information in the form of 7-segment alpha numeric displays, character LCDs, graphics LCDs on a television screen. You may want to output sound through using a speaker or buzzer. You may want to control temperature with the help of a heater or a Peltier module. The Peltier module, nice thing is you can heat as well as cool. You may want to control position of a device, and you can use a stepper motor or DC motor and things like that for that. You may want to control flow of liquid or air with the help of a valve or a pump. You may want to give haptic feedback to the user. We often use it in our phone. Whenever we are typing something, we get a haptic vibration. It is achieved through a motor and an asymmetric load connected to the motor. Or you may want to output information in the form of a print device. You could use a thermal printer or a dot matrix printer. Now, modern microcontrollers, there's a huge plethora, huge variety of microcontrollers. You have 8-bit microcontrollers, you have 16 and 32-bit microcontrollers. And if that is not suitable, you can even have soft core that you can implement on FPGA. You can implement your own processors, or you can take third-party, soft core and integrate them on the FPGA. Another classification is that processors could be 8, 16, 32. You could have RISC or CISC. The memory is in the form of ROM or E2PROM, and flash memory for program storage, volatile memory for data storage. You have digital inputs and outputs. You have communication interfaces. Communication is very important in our present situation for IoT. Then you need in-system programming and debugging. And for that, there is a JTAG interface. And most modern microcontrollers will have a lot of peripherals, such as timers, counters, PWM generators, watchdog timers. Watchdog timer is a special timer that keeps track that your program is not gone haywire or something like that. If that is the case, it will generate a reset signal. And then analog to digital converter, as well as digital to analog converter. All this in the packaging from 6-pin 128 pin. As you can see on the right hand side, I have two figures. The top one is a microcontroller from Texas Instruments. It's a 128 pin TIVA 32-bit ARM microcontroller. And at the bottom is a 6-pin microcontroller from Atmel. This is called AT Tiny 10. And for comparison, I put grain of rice and SMD resistor, LED, and a capacitor for comparison. And as you can see, the grain of rice is bigger than all these devices. So this is the kind of physical, range of devices, size, relative sizes that you can. If there is any question about any of the things that I'm talking of, please ask. Then these are, 30 to 40 milliamperes of source sink current capability. Each input pin can have weak or strong pull-up, or you can, implement tri-state capability. Each pin also offers multiple functions, one of which could be selected using your program. And oftentimes some of the functions may be available on multiple pins so that you could utilize all those functions. The flash memory for program storage lies in the range of a couple of kilobytes to few megabytes, and you can lock the program so that your intellectual property is safe. The SRAM, that is the volatile memory for data, is in the range of 0 to tens of kilobytes. Then oftentimes you would have a EEPROM for semi-constants, meaning something that you can change over a period of time, again from 0 to few kilobytes. And many of these microcontrollers internal clock source could be RC clock with trimming. Also, it offers clock scalability. Clock scalability means that at runtime, you can change the frequency of the clock. And modern microcontrollers have multiple clock BCC domains. You will find that your microcontroller just doesn't require 5 volts or 3.3 volts. It may also require 3.3, 2.5, and 1.2 volts, and so on and so forth. So these are some of the characteristics. There are some more characteristics. They modern microcontrollers have low operating current from 1 milliampere per megahertz to 0.1 milliampere. The reason of this linearity is linear dependence on the frequency is because of the CMOS implementation. It offers broadly three operating modes called active, sleep, and power down. And using sleep or power down, you can reduce the power consumption. It has wide supply voltage from 0.9 to 6 volts, and the core voltage is scalable. You can change the voltage, operating voltage, and that way you can also conserve power. There are multiple reset sources. They're called power on reset, user reset, brownout detector reset, and watchdog reset. Watchdog timer has an independent clock so that even if you shut down the main clock, the watchdog can continue to work. The brownout detector usually has a programmable threshold so that you can decide at what voltage dip do you want the BOD to kick in. Then these devices have mixed signal capability. And the mixed signal capability has hardware DSC, either through independent DSC or through PWM. Then it also has independent analog and digital VCC. So this is very important when you are designing a system. You should be aware that your analog signal pins, analog supply pins are different from digital supply pins, and you should not join them together. It will offer timer and counter, which may be 8 or 16 bits, and it would have high frequency PWM with various options. Then it offers general purpose communication through UART, SPI, I2C, and one wire. It may have specialized communication using CAN or LIN or Ethernet, and sometimes USB. It may have Wi-Fi, Bluetooth, low energy. It also covers in-system programming and what is called in-application programming. It offers on-chip debug. JTAG is a common protocol for on-chip debug as well as in-system programming. And oftentimes, if required, the peripherals may have DMA capability. Then you require development tools for developing application. You need a development platform, usually PC, assembler, cross-assembler, simulator, evaluation board, program download tool, and emulator or on-chip debugger. we developed many platforms for developing applications for embedded systems as well as IoT. This is one of them. Is another one. And we also developed then when you are designing a system using a microcontroller, it requires four important elements. I call them roti, kapda, makan, and internet for a microcontroller. And they are clock, reset, power supply, and program download capability. Why do we need clock? Because we are talking of a digital synchronous system. What should be the clock frequency? It will depend on what kind of computational requirements we have, what kind of power we are able to dissipate. Because these are two, if you want higher performance, clock frequency will be higher, but it will also lead to higher power dissipation. What should be the topology of the clock generator? Do we need RTC? Is the RTC required to be very stable, in which case you may have a what is called as a TCXO, temperature compensated crystal oscillator, or another option is you have a temperature sensor and varactor diode for stabilizing the clock frequency in a real-time clock. Now selecting the controller, there are so many controllers available. Question is which whether it is embedded system or IoT, basically whenever you are sampling analog information, you know that you must maintain, conformity to the sampling theorem. So if you know that the input information has certain bandwidth, you must sample it at twice the rate. And so that decides the intersample interval. Now, once you take a sample, what do you do with it? You have to process it. And the processing is going to be done by the microcontroller. If it takes too much time to process that information such that it exceeds the intersample interval, in that case, that controller is unacceptable. You see case B, in which it is just able to finish the computation before the next sample arrives. Here it's a marginally acceptable. And in the case of C, it is quite comfortable because there is a lot of margin available, a lot of time available. Tomorrow, if your computational requirements change, even then this microcontroller can handle it. So you must select a microcontroller which is of type B or type C at least. Type B at least. Type C is very ideal. And so this is a mathematical method of looking at which microcontroller is suitable for a given application. Then you have the reset. Why do you need reset? Because when the system gets hung, you have to start it from the same source. So knowing about reset, what are the various sources of reset is very important. And then we have power supply. Power supply is one of the most critical requirements of a embedded system or IoT design. Oftentimes you'll see that these days the microcontroller has partition design, meaning there are multiple supply voltage requirements. And the reason is that once you have a higher frequency, your supply voltage has to go down. And if the supply voltage goes down, then your noise margin will have a problem. So they have divided the chip into 2 or 3 parts. The peripheral part of a chip, the outside for connecting to the outside world, is usually powered with a higher voltage so that it can have a better noise margin. Then modern microcontrollers also have an analog subsystem, and they would have their own independent supply voltage. And then the power dissipation, as you know, for a CMOS circuit is some constant into the frequency of operation into the VCC square. So you must keep that into mind. Then source of power, is it grid, battery, or alternative source? What is the battery technology? Are there any scavenge sources? And what is the level conversion mechanism? Meaning, are you using any voltage stabilization unit? If you are using switching, is it buck boost or buck boost? These are 3 popular methods of power supply regulation. If it is grid power, are you taking care of the polarity of the input? Then regulator, is it's linear or switching? Linear regulators are very easy to use, and the older types of 780 series, 78 series is no longer viable because they have too much power dissipation. And so these days you go for low dropout, low IQ linear regulators. And if you want to save more power, then you go for switching regulators. But it is more expensive, it requires more components and board space, but they are more efficient. This is power, the input polarity proofing the input stage. These are various types of linear regulator topologies. These are the three terminal linear regulators. As I mentioned, 7805 is history. Nobody uses that. There are alternative, what are called as LDO, low dropout regulators, which have low quiescent current and low the dropout voltage, meaning the difference between input and output voltage. And there are some examples that I've given. Switching regulator. So in modern design, oftentimes you use a switching regulator. The exact type of regulator will depend on what is the input voltage and what is the output voltage. This is broadly, there are three types, as I mentioned: buck, boost, and buck boost. This is an example of a buck where the input voltage is higher than the output voltage. And this is a common buck regulator. Then this is the boost where the input voltage lithium battery driven application, you require what is called as a buck boost regulator. If the input voltage is between 2.5 to 5.5 and you want output voltage to be 3 volts, then you can't have buck, you can't have boost. So you have a device which is called buck boost. It switches between buck and boost depending upon what is the input voltage at that time. Then there are various topologies of the power supply, where depending upon transformer, linear regulator or switching regulator, and so on. Here are another few more topologies. You can use lithium battery with boost or lithium battery with buck boost, and so on. Here is a case study of a linear power supply for embedded processor. As you see, the requirement are three supply voltages: 1.1 volt, 1.8 volt, and 3.3 volt. And the power, the current through each of the regulators is 0.6 ampere, 0.3 ampere, and 0.2 ampere. And if the input voltage is a fixed 3.7 volt and you have a linear regulator, you see the total efficiencies for first one is 30%, 50%, and 90%. And in this may not be very acceptable. So but that doesn't mean you replace all the linear. There is no advantage of converting the third regulator to switching. So you see a better solution would be that you have the first two power supply voltages, 1.1 and 1.8 volts, to be of the switching type, and the third one can still remain linear, and the efficiencies have increased from 30 and 50% to 92, 93, and 89%. So you as a designer must exercise good judgment. It is not that every regulator should be switching regulator. You can also see whether a linear regulator is suitable for a given application. Here is a TPS 61085 power supply using a 3.3 volt source. You can have 5 volt. You can also generate -5 out of this. Power optimization, one must consider three broad levels: active, sleep, and power down. Almost all modern microcontrollers are offering these methods now. Here is a power supply versus power consumption versus supply voltage curve. Sources of power, you would look at batteries if your source is sporadic. You can also think of using supercapacitors. Supercapacitors are very large capacity capacitors, hundreds of farads, and they have much longer life than batteries, and they are also not using any harmful chemicals. These are various types of batteries and their characteristics. You must consider these characteristics when you are making a choice. And then the last important thing is what are the program download capabilities? JTAG or in application programming, various methods. Then, of course, communication. Without communication, you cannot handle modern IoT devices. And electronic glue, as I discussed earlier, uh, depending upon various applications, you may require to design amplifiers and filters or power switching circuits. So these are IoT related activities at our place. IoT enabled astronomical photometer, doorbell, fridge, pedagogy platform. And these are the references that I've used for this PPT. I'd be very happy to answer any question that you may have regarding any of these topics. Thank you. Naman?
So if anyone is having any question or any query, so one can ask to sir, or you can just mail your query to sir as email ID and WhatsApp number mentioned here. And also you can send to me also. I will definitely send to sir your query. So sir, if there will be any, so I will definitely mail to you, sir.
Okay, thank you.
So thank you very much, sir, for giving in detail the leaf node characteristics and input and output to the leaf node, and then modern microcontrollers properties and features, and then IoT framework. So definitely all the participants will get benefit from this lecture. So thank you very much, sir. Thank you.
Thank you. Bye.
So next lecture will be going to start in a while. So till then you may connect. Okay. So in 5 or 10 minutes, next lecture will be going to start. One of the participants has asked a question. So definitely I will circulate this question to sir. And as soon as I got the answer, I will definitely revert back to you. Okay, man. Good afternoon, Karan sir. Now you may unmute yourself and also you can just share your screen.
Hello.
Yes, sir, you are audible, sir.
Now is okay?
Yes, sir, yes, sir.
Okay.
So, sir, we will just start in 2 to 3 minutes.
Okay, no issue.
Yeah.
Now is okay, Naman?
Yes, sir, your screen is visible, sir.
Okay, thank you.
So I think we may start now. Uh, all the participants, we are moving towards the last session of today's, that is overall ninth session of this FDP. So we have with us Dr. Karan Verma, sir. So I would just like to give a brief introduction of Karan sir. So Karan sir is presently working as a assistant professor in the Department of Computer Science and Engineering, NIT Delhi. Sir has completed his BTech from Rajasthan University, and after that MTech from IIT Roorkee, and then PhD from UTP Malaysia, and postdoc from University of California, USA. Sir has published 14 SCI papers and more than 15 conferences and more than 5 book chapters. And also, sir has completed or undergone 8 national as well as international collaborative research projects and 2 projects under TechCube 3 scheme of MHRD. And sir is deputy chief under deputy chief warden and TechCube coordinator at NIT Delhi. So we welcome you, sir, at our FDP for your lecture.
Thank you, Naman. And good afternoon, all the participation to participate in FDP. Today we have to take the topic for IoT based air and sound pollution monitoring system. The previously we are taking only for air, but I'm thinking to combine to take it air as well as the sound population air and sound monitoring system. How can they are affecting in your real environment using the IoT. Okay, so we can start. First of all, we have to go little bit about the basic introduction for IoT. You already, this is the 9th session, so you already know about the IoT, but I am little bit start with the basics, then we can go with the monitoring system, and then I will show you one here I'm show you one undergoing my project, some slides, with your presentations, just like for some demos are available. If you require, then I will show you some codes also, and hardware requirements, software requirements, maybe the MTech students or the if the PhD student to work, and this topic may be the useful for further. Okay, so we can start with the IoT. The IoT basically is the network devices. And network devices means network devices are two types: connect to connect and disconnect devices. Disconnect devices means they are wireless connected and wirelessly disconnected. Okay, they're called the Wi-Fi. So we are talking about here the Wi-Fi devices, because all the IoT devices, most of devices are connected to the some basics Wi-Fi facility to use them, and then their topology to implement in further connections. Okay, so what is the IoT? IoT is the connectivity device with each other capture and they share the data through the secure service layer. The secure service layer, you already know about the computer network. In the computer network, there are a lot of layers are there, and they are secure services layer. And the secure services layer is the called is the transport layer. Okay, network layer and the transport layer both are combined together, and we can call is a secure service layer that connect to the central commands and control serve in the cloud. Okay, that's why I am telling we are taking about the only for Wi-Fi devices. Okay, wireless device, wired devices also be there in the IoT, but most of things are connected to the Wi-Fi. That's why some server cloud devices are available. Maybe the uh, man-to-man services are there. These man-to-man services are utilized by the cloud. Okay, this is the first important steps. The second thing is the uh, he's using for people collection, record the data, analyze the data, not just the healthcare, but is every industry today. Okay, so there are some data connected by the IoT devices. These IoT devices, whatever data you are connected there, these data, how can you to be, we can say this is the uh, uh, simple language. We can say, what will we say? Simple devices is IR. What is the IR? IR is information retrieval. What is the information retrieval? The information retrieval means whatever information you have to travel through the air, you have to receive by the proper channel, and these proper channels are secure, and most of things are connected through the cloud devices. So whatever information to travel to the cloud, to the air, everything have to be analysis, record properly, store properly, collect properly, and then they have to be analysis. Okay, this is the some basic IoT devices utilize, and the idea of devices directly reach each other, basically called the Internet of Things. This is the simple basic idea about the Internet of Things. There are three different definitions. This is the figure about the internet. These internet you know already about that all the devices are connected to this IoT, just like all the industry, healthcare industry, transportation industry, agriculture industry. There are a lot of things are there are connected to the Internet of Things. So Internet of Things nowadays is very useful. Okay, is major component to link internet to everything by the sensor and the working devices. Okay, there another things are connected here, just like for cloud and edges. Okay, what is the edges? The edges is the all the cloud services providing to the nearby the users. Just like for I'm using something, so cloud is not available in, just like server is something else place are already stored there. So what will we do? These virtually are connected to the cloud devices, and the cloud devices are connected to the edge devices, and the as devices are connected to the users. If your user requires, the as provide the all the platform applications to the cloud to the particular users. Okay, this is the simple uh, working style for IoT devices. And smart objective, the smart objective play the important role for IoT. These IoT, the informations and the other utilize of all the things have to be changes. Okay, about which devices are connected using the sensor devices. They recognize the condition via built-in connecting power. Other devices are connected and interact with the each other. What is the meaning of interact with the each other? I just give you one best example for these internet of thing. Everyone is using the Amazon. Everyone uses Amazon. These Amazon, they are, you are suffering for last 1 month. Some stuff you are suffering, you are just check and you are not buy the things. You are buying for something else. Okay, so they have recommended system. These recommendation system, what will we do in the whatever time in the next time you suffering to the Amazon, these Amazon provide the all the whatever you search for last 1 year, they will provide you same utilize things in your web pages. Okay, this is the same thing here. The IoT, the sensor data to sense the data, all the information, and the next time they work in the same time. Okay, they check whatever you requirement, they will check it there, utilize the things, and then build it connection. Okay, this is the simple example for IoT. Okay, the basic about the basic benefit of IoT equality network. This is the personal Wi-Fi on your smartphone and on many other devices. Everyone wants as well as need to be connected. Okay, this is the first thing. The second thing, connected computing. Connected computing, we want all the devices, smartphones, television, DVD player, vehicles to keep record of what we are doing, sensing, reading, listening, or as we say, throughout the day from one place to another. The handoff all the devices of devices is happening already. This is the connecting computer. And the third one, we can say analysis as a services. This is the API based economic services. They do sometime interesting as long we are connected each other. The think is a data generator as well as the collection that earn from make forecast and make a be and make be even takes data devices action in the response to the data at all the devices are connected. This is the third step. The marketing is just like for smartphone customer engagement, just like for we can say the buying patterns, which type of buyings you are patterning, knowledge the pattern, implementation, time deadlines, time delivery, how can you deliver the functions. These things have to be in the IoT. And the supply chain, you already know that they have supply chain delivery, the just in time produce, or the time in the just like for RFID, ATM machine, automobile manufacturing company, the other devising. The IoT is monitoring, watching, as well as for waiting for the product need to be arise. Okay, this is the supply chain have to be checked and utilize the things. Now, monitoring benefits. The monitoring benefits are is air quality monitoring help us to better understanding the source level of different air pollution, effect of air pollution, control policy, and exposure the various substitution in the air we breathe. Okay, this is the monitoring system. They have to check what is the air quality monitoring to understanding the source devices, level of different air pollution, just like for different type of air pollution is there. We can know about all the policies the policy generated by the government as well as the private institutes, private industry also there. They have to be monitoring all the devices. Okay. The second thing is air quality monitoring program assign us to improving and developing air pollution control program to reduce the efficient of air pollution. Okay. The second thing, air monitoring system. What will we do? The monitoring system have to be implement and develop to the air pollution control programs. These programs to reduce and efficient for air pollutions. Okay. The third thing is the purpose of air pollution is not mandatory to collect the data, but also is provide the information necessary for engineer, scientists, policymakers, politicians, and plan to make the information decision and manage and improving the air environment. Okay, so these things have to be monitoring gives better and better like that. The second steps is air quality indexing. You already know about the AQI. Everyone know about that. There are a lot of apps are there to check the AQI. The AQ high level AQI is there, or low level AQI is there, and middle level AQI. Okay, so AQI help to understanding the level of which air is polluted and associate with the health effect and the might. Okay, they check by the two things. Polluted air he check also in associate with the health effect also. Okay, then second thing is the he will check also lot of different matters, ground level, EP, EPA calculator to the different type of the five major air pollution check. This air five measure to provide the better air quality and the worst air quality. Okay, this is the factor to be to identify in the air is properly work or not be work. Okay, and the third thing is there for each of these, all the EPI has check the quality of standards to protect public health. Okay, they have air quality, we check the quality as well as for protect the health. uh, how can you the health to be effective manner. This is the AQI. I'm taking one example. These three different, this is the table to check it there. The first thing is air quality indexing, AQI value, level of health conscience, and the colors. Okay, there are three columns and three rows are there. These rows, if you are AQI is 0 to 50, then they are good and they are showing as a green in the your app. If they are getting AQI is 51 to 100, then you have to be little bit conscious. Okay, and they are showing just like a yellow. Okay, if AQI is 101 to 150, then this is not unhealthy. Okay, and this is showing this is the giving to the signal this is not good for your health. Sometime in Delhi there are a lot of issues generated. Sometime, most of time nowadays, today we are checking the air quality of air in my area. They have to come in orange zone. Right now I am in orange zone, means I am not healthy air to take inside my body. Okay, the one if you are comes by the 151 to 200, this is the unhealthy, and this is the red zone. If you are red zone, supposed to be you have to leave the place to better for your health. If you are 201 to 300 is very unethical or unhealthy. So purple curls will be showing that, and 300 to 500 means this is the worst air condition for last stage, 301 to 500, and this is the maroon color showing. And last year I am seeing that in the January end in Delhi, in Narela area, uh, we are air quality is around 450. That time we are using on mask. Without mask we can't take the air because is un uh, damage your body for by small particles. Okay, so supposed to be, if you are check, there are a lot of apps are there. In the apps you are seeing that they have different categories. These categories to identify the AQI, and these AQI, how and where and which topology they can use them, we can uh, understand for further presentations. But first of all, we can know about the what is AQI, what is air monitoring, what is IoT. We know a little bit about the introduction, then we can go slowly we can go to learn about the all the different devices things. Now the air quality standards. Okay, we know a little bit about the basic knowledge for air quality standard. Air quality standards are there are two type of air quality standards are there, primary as well as the secondary. Okay, if the primary standard is using for just like for children's and the using that, and the secondary uh, just like for standard is protect public welfare, including protection against the different type of these things are there. Okay, so the two type of air quality standard, the primary standard and the secondary standard. Okay, and what is the clear air developed national, this is the air standard protocol public health environment resources. Okay, so these resources are connected by the two things. First is for to the primary level, and the second thing is are connected to the secondary thing. Okay, these things have to be identified for standard generated. These standard have to be generated by the national government, and these national government providing the standard, which standard right now is going on. This is a this is the example, or this is the table for January 2010, and this table you have to be know about the primary standards and the secondary standard, and these standard you can check it there. All the standard have to come. Okay, they have orange zone, red zone, they have different zones, and the levels and then the timing and all the things have to be, you can verify it here. Okay, now the this is the zones to comes here, uh, NAAQS revisions, and 2000 Jan EPA proposed a further lower to 8-hour primary zone standard for 7:55 p.m. set in 2008. Their standards are there. Okay, so they this is not our consent area. We just know about what is the zones and how can you work for NAQS, but our main target is to be know about the how can you work it there. Okay, there are some they are research work, or this is the proposed work, SO2 revisions. How can you they are working there, they're proposing SO2 EPA taking comments both or 24 hours SO2 standard, then something have to going on. Okay, their standards are there. If you require, if you need, then I will share this PPT. Okay, then the solutions are, these technique are three type, and this is the market based solution, technical solutions. There are different solutions are there. These solutions you have to pick that and to be identify the goals whatever you can achieve then, and these achieve goals for a technical, how can you technical effective, how can you economic effective, and how can you do for just like for population of air and the sound for increase rapidly, so bring it under control is monitoring for major nowadays is very concerned area. Okay, these parameter for we can just like for air sensor and recognize presentation helpful for system keeping monitoring, and these monitoring system have to be understanding better and better resources. Okay, and this is the monitoring system. This is the typical monitoring system in Europe. This monitoring system to identify, they are collecting the data, these collecting the data to be identify, and these identify the data, check the connectivity, air quality. They have to take the particles as well as they are taking the sensor air quality, just like for air wing, which direction the air will flow, and these things have to be monitoring. And the collecting the data, they are collecting data the weekly, as well as they're collecting the data, we can say the collecting data for monthly. Once the once they are connecting data, then after the connecting data, after uh, we can say generating the result, and these generating result to be identify different type of policies are there. Okay, now this is the examples to identify. There are different monitoring systems to be just like for now there are two things are there: indoor air pollutions and outside the air pollution. Okay, they have different air to check to the monitoring system, and these monitoring system to identify different platforms. Okay, and these platform to identify to identify all the devices, just like for CO identify, as well as NO2 component and consume opportunity happening to the atmosphere to the health monitoring, as well as the AQI maybe to be a little bit concerns about the, he will check the parts ppm is the parts per millions, maybe the similar unusual air quality population. These things have to be identified, just like for some sensor for to check only for CO, some sensor will generate it for wireless sensor network, some are using for abonionion, and some are using for different type of whatever inputs comes here, they have to check the outputs is there. Then this is the monitoring devices. The these monitoring devices to be different charactery also there. The first is monitoring devices, we can say this is type of monitoring forcing emerging coming out the nature and the main made sources. Okay, whatever main made sources comes here under this monitoring system have to come. The second devices are connected to the toxic as well as non-toxic components. These components have to be identified, the we can say the values, and to be execute one by one. The third one, ability to see think is the primary focus of the type of monitoring. Visibility monitoring is to visible all the devices, just like for here they have some here, the the second, third, fourth and fifth not they are just air to take it there. This is the visibility monitoring system. These visibility monitoring system to whatever visible things are there to identify. Upper air monitoring, this is the upper atmosphere with the help of satellite to identify the value, and we can say check it there slowly. And the health monitoring system, the health monitoring system to identify to the health, as well as we can check it there whatever health issues will generate it, then we can study here. The monitoring system, different type of air quality monitoring system is operation today nowadays. In they have a lot of operation is there going on. They have some useful information is there. Some Mexico is going on, Canadian air monitoring system is going on, Mexico network is there, health monitoring program by the WHO is there, satellite monitoring system for NASA and NASA as well, and US EPA, and some atmosphere integrated research monitoring network in US, and some embedded air monitoring program in US. There are a lot of program monitoring system is going on. These monitoring system to identify the air, as well as they have to check what is the useful, just like for AQMS air quality monitoring system is going on in India, and these monitoring system to identify where the monitoring all the gas sensor network is there. There are a lot of things are there going on. We can check, we have to require the lowest, our main goal to be providing a real time lowest monitoring system. We require real time as well as low rate monitoring system over the use of low rate low information rate and little control wireless communication devices. Why we require the real-time system? Low rate means our the cost will minimum, as well as we required the control communication techniques. Overall communication technique also is better, as well as we required for information rate is higher. Low information rate. Low information rate means error rate comes as reduced as possible. Okay, this is the things are there. This is the monitoring instrumentation. These techniques to be used for air quality to identify, just like for air measuring devices are there. There are a lot of things are there, CEMS, and these information to be identified. This is the basic devices, and this is the figures to be whatever information is there is physically are connected in world. I'm taking some snaps to be know about the monitoring devices. Okay, these the plans and characteristics. This is the basic introductions. Now we can go for, this is the rates are there, and this is I'm just planning. The planning is just like the major points consist during these steps. We require some plannings. How? The first thing, we can take the data. Step to be taken, where will be taken? There are a lot of techniques are there to collect the data. These collect to data to identify collection method. They have three methods are there to collect the data, and data from literature. They have a lot of data collections from different sources are there. Then after the information during the collection, during the data collection, this is the information to connect the general source information, location, on ownership and nature of the business, and this is the things are there. This is the basic introductions are there, and this is the response data, and these things, air quality pollution in India, and this is the important for climate protection. This is going on right now. 2019 started in Europe, and this is the CO2 to be monitoring the system devices. Okay, this is to be basic introductions. I cover them. Now we can go for our proposed model, which going on my project. This project main objective to IoT air and the sound monitoring system is that the air and sound pollution to getting larger these days. Okay, it is necessary to detect air quality, and the keep is under control for the better weather and healthy living for all. Okay, this is the proposed work, and this is my block diagram. Okay, these block diagram, you are saying that they have lot of things are there, so I will tell you. This is the transformer and receiver, a 5V and 3.3 regulator, Wi-Fi mode, LED devices, and the gas sensor and the sound sensor. Okay, and the models use air sensor recognize to providing the better result in the offices, as well as the different diagrams. Just like for I'm coming one by one to tell you. This is the overall figure. I will tell you one by one which hardware we can take it here. First of all, I am taking the first hardware devices, MQ135 gas sensor. Why gas sensor will take it here? Because the gas sensing devices to sensor the air quality. So these sensor what are doing, MQ135 is the clean air providing these gas sensor generated by NS3, S2, and C6S6. Okay, and sensitive to smoke and other harmful materials to be detect them, and it is with the low expensive and suitable for different application. This is the very cheaper sensor devices. These sensor devices to be identify to the gas components, and to be differentiated with the sensor connectivity with the low package along with the gas connectivity sensing devices. Okay, this is the just like for convert changing to connectivity the panel output signal of gas emissions. Okay, this is the simple hardware devices, first hardware devices. This is my second hardware devices is sound sensor. The sound sensor is MIC as a sound sensor in the uh, my proposed model. These sensor operate on the 3.3 to 5 V DC. Okay, this is the DC output. To take it is provide the digital output on the display to detect the sound from the atmosphere or atmosphere, and the output digital target signal. Okay, it has a sound set pointer rejection, and he checked the threshold value. If if the reading goes beyond the threshold value, automatically we'll be able to know the sound population is at the high level of the particular place. Okay, my threshold value to decided, he will go for high level and the low level. Okay, and the next thing is Wi-Fi model. The Wi-Fi model we are using ESP8266. This is Wi-Fi model to leading IoT devices, because this is the most important Wi-Fi model. This is the chips and everything are connected here, and leading IoT devices on the world, which is the very effectively hardware devices working for 3.3 voltage. Do not power it with the 5 voltage. Okay, so his goes under 3.2, 3.3 to 5 in between. Okay, and this is the inexpensive devices make our work. And these microcontroller, this microcontroller have to lead the devices of major project. Okay, now microcontroller we are using a 328. Okay, these microcontroller 32 kilobytes ISP flash memory with a read and write capacity. Okay, and 1 kilobyte EEP ROM, as well as 2 kilobytes SRM, and as well as 23 general purpose input and output line. Okay, they have 23 input and output line and 32 general purpose working generator or registers. Okay, there are 32 proper generator registers are there, and 23 general purpose input and output lines. Okay, and 3 flexible timer and the controller with the compare model, internal and external interrupts. Okay, 3 flexible time or counter with the compare modes, internal as well as for external interrupts. Okay, and this is the diagram after you work for, this is the microcontroller board. This microcontroller board is called for 80 mega 328p. This is the 14 digital output. There are 14 digital input and output pins, with the 6 can be used as a PWM output, and 6 analog input, a 16 megahertz quartz crystal. Okay, as well as USB controller, power jack, ICMP header, and reset button. Okay, these things are combined here, and he's supposed to be UNO. UNO means it come from Italian and is chosen from the IDE software. IDE software is 1.0. We can use them. Okay, IDE, there are a lot of softwares are there we are using for uh, first series of USB Android board. Okay, this is the Androiding board. This Androiding board we are using for version of 1.0. Okay, this is the technical specification for these hardware devices. We are using for microcontroller 80 mega 328p, operation voltage 5 volt, input voltage 7 to 12 volt, input voltage limitation is 6 to 20 volt. Okay, digital input output pins is 14, PWM digital input output pins is 6, Android input pins 6, and DC control current input output pins are 20, sorry, DC current of 3.3 pins is 50. The flex memory is 32 KB, as well as SRM 2K, EEP RM ROM is 1 KB, as well as for cloud spent speed is 16, length is 68.6, and the width is 53.4. Okay, this is the technical specification. This is the pin diagram. I'm telling one by one. First number is the power USB. You know that the power USB. The second thing you can say the power, the jack. Okay, power jack. And the third one we can say voltage regulator. The fourth one is crystal oscillator, and 5 to 17 is reset pin. Okay, reset pin is pins are 3.3 to 5 GNB V in. Okay, 3.36 is supply voltage is 3.3 output voltage, and 5G is supply 5 output voltage, as well as 6 7 8 9 ground pins are connected to the LED. Okay, TX and RD is TX is transmitter and RX is receiver. Okay, there are two places are using for 14 number pin. 15 number pin is digital input output pin, LED pins are there, and 16 is AREF. Then Android reference. Okay, wants to be set associate in nursing extension references to voltage between the 0 and the 5 voltage. Okay, this is the things have to be in. This is the overall diagram. This is the LED 16 into 2. You know that this is the things. I will tell you. Pin number 1, this is the ground, and we can say this is the source pin, and this is the working style is there. This is the ground pin for LED connected to the ground to MCU as well as the power sources. Pin number 2, we can say VCC. Again, this is the source pin and connected to the supply main to the power sources. Pin number 3, we can say V0 to V0 or VEE. This is the again not the source pin. This is the control pin. This is the connected to the variable port with the voltage of 0 to 5 volt. Okay, then pin number 4, we can say register selection, and this is again control pin and connected to the MCU pin and get to the 0 and 1. Okay, 0 is command mode and 1 is from reset mode. Okay, or we can say read and write mode. Pin number 5, read and write. This is again control pin connected to the MCU pin and get the output 0 and 1. 0 means read and 1 is the 0 means write and 1 is the read. Okay, pin number 6. Pin number 6 is connected to the enable this enable pin, and this is the control and connected to the MCU and help to the performance of read write operation, and always higher priority they will provide you for on the devices. And the 7th to 14th, 7 8 9 10 11 12 13 14 are connected to the data bits. Data means data and command pins. In only 4 pins 0 to 3 connected to the MCU, and the 8 pins are connected to the MCU to find the data to the particular sources. Okay, pin number 15 are LED positions, and the LED positive, these positive to identify to connectivity with the 5 voltage. 16 is LED negative, and this is connected to the ground floor to provide the the source information. Now the software requirement, which software we can use for IDE. This is the, I am taking one snapshot for these software. This software provide the text editor, write and read and write program, and the other things have to be generated here. Okay, and this is next thing is we can say IoT online open source development platform. We can say IoT GECKO. Okay, what they are doing, they are providing the various features such as control, digital objective, as well as forwarding a new dimension of the internet. And these dimension of internet have to be identified, monitoring machines, monitoring stuff. You can IoT is using that, as well as they have provide the cloud platform for open door for new dimension with the API support overall the microcontroller, PI, as well as the other controller board. Okay, they are providing the control with the hardware and the software devices, and their features are there. These features are effective GUI builder, process sensor value, overall IoT, operate monitor our IoT, two-way communications, develop enterprises level IoT devices, and online development supported. These things have to be done it there. These GUI as well as IoT layout, online monitoring system, these monitoring system to be identified to the different platform. Okay, this is the overall circuit diagram. This circuit diagram we are connected. How can they are connected? I will tell you one by one. Hardware devices, which devices they are working there. The hardware first of all connected to the providing the voltage 5.5, and the 3 are connected to 3 volt, and the Wi-Fi modes are also connected, and the sensor network to be used MQ7, MQ6, and MQ135, and LM35 square major use there. Okay, and other things we can use them. We can say one MQ135 devices for using identify NS3, alcohol and smoking, other devices to be identified, and the population level of ppm part of the million to the 135 to be identified. Okay, this is the devices. And how can you work there? When the ppm threshold value going on, the LED display, the screen is face air and the bottom air. Okay, we can show you one by one, then you can know. And this is the flow diagram. This flow diagram to be better to identify how can you these them. They have 3 diagram. These diagram we can say the Wi-Fi. First test the Wi-Fi model by the given AT command, and it give back to written okay. After we can give the command AT plus CW mode equal to mode ID. We have used mode ID equal to 3. After Wi-Fi mode AT plus RST reset, the operation started. Once the operation started, we can use for AT plus TW JAP equal to Wi-Fi about the username, and the Wi-Fi equal to password. Once they give you username and the password, then after IP generated, and the IP command AT CIF SR, and IP returns the value. Once the IP return the value, after generating the IP web browser, we can press the key, which key we can use for password key, use the different transmission information to the web browser to identify the value. Okay, this is the diagram. This is the hardware implementation to be better identify. First hardware is overall figure the value, and then after this is the monitoring system, the population monitoring system, and this population monitoring system to identify the second thing air quality. This is the second system to be identify air quality. this identity to be, the value will be gone. Okay, and the next thing, this is the air quality for 3479 ppm fresh air. If the fresh air comes here, they showing here. Okay, next is like that, the air quality 149 for ppm. Okay, they are showing if the air quality comes here ppm, then they have to come showing here. If the gas detector providing the worth of 90 ones, there are no gas shift there, and also their safe level of air quality started from 350 pm, then up to 2000 ppm, then we can check the multiplications of different disease number. Okay, this is the source population for detective, for we can say this is the DP to measure identify. This is the overall figure to identify. This is the flow chart. This is the flow chart to be a little bit about how can you they will work to the uh, we can say different type of we can say different type of monitoring system. To they have sensing the data, analyze the data, then after analyzing the data to identify the value. Okay, just supposed to be we are we can say uh, I'm just taking one example. We can say circuit devices are connected, just like for we can say simply say the Wi-Fi model are connected to the Android. Android is ESP 80826 run on the 3.3 volts, and if we can supply 5.5 volt from the hybrid devices to the output devices, and the output devices we are connected to the VCC, and the we can check it then ch underscore pd about the 3.3 volt pin in Android, as well as the RX pins are connected to the Android system, and these Android systems are connected to the 9 volt to 11 volt. These 9 volt to 11 volt are we can say circulate are connected, and to identify the value. Uh, these value are implement to the other devices, and then after once they are connected to the devices, automatically they are disconnected here. How they are disconnected here? Just like for there are three tables are there. First of all, we can say the first table we can say first of all we can set the value of AT plus CW mode, and these modes are connected to the Wi-Fi username and password, and these Wi-Fi username and password are reset the value of different levels. Okay, just like for uh, just like we can display the web page of the fresh air whenever the worth can be increased of 1000 ppm, then the buzzer can the keeping and also show the LED digital display, and digital display we can say the pure air comes in your window, and if the poor air comes to your window, you have to be close your window. Okay, if simply say if it can be increased 2000, then the buzzer can keep bringing and also show the LED display. This is the danger, move to the recent air. Okay, move to the recent air. As well as we can say using sound detector, we have to be technically to notice close sound. This board to be injected with the mic, as well as the compressor, as well as the little enhanced economy, just like for circulate for LM 386. These 386 results is surely to make would be or would not be ready to send the signal of Android. The alternative sound will goes to the VCC, GND, as well as the signal. Okay, uh, within the middle of the plate, and these middle of the plate, this is the flow, this is the diagram, and these sensing data to be providing the connectivity of AN and rock part to the generated vehicles, and these vehicles to be identified to the different models. Okay, this is the simple topologies are there. Other techniques also be there. We can say what will we say, we can say wireless sensor devices. Okay, uh, which type of problem we can facing that? There are two type of problem we can facing that, and the first thing we are facing that poor air quality in the area with the purely connected to the industry. The second thing, smoking area and the fireplace, the major source for the implementation. We can do it IoT model, the IoT model for injection, the compute devices, mechanical and digital component. These component for connected for the LED display, gas sensing devices, temperature sensing devices, and audio speaker devices, and Android different devices are connected. Okay, and these sensor interface, which interface we can using then? VCC, GND, VVOT, as well as GND, or these ND have to work for just like for we can say ADC. ADC is working for 1024 2 to the power 10 decreasing Android system. Okay, these Android system have to work then, and command panel we can text them TX to the pin to the control point protocol devices connected to the receiver point of connected devices. Okay, so uh, first of all we can check it then the gas of CO and NO2. Okay, there are two devices are connected, we can check it by the sensing devices CO and NO2. Sensor are developing two different things are value to identify different things. Okay, this is things are there. Okay, I think so. This is the flow chart, this is the diagram, and this is the things. I think supposed to be completed my talk. Thank you. Naman.
So thank you very much, sir. Thank you very much for your live demonstration on IoT platform, how we can develop IoT, and as you show how we can measure the air pollution as well as sound pollution. So I hope all the participants will get benefited from your lecture and they can do work in the field of monitoring of air pollution and sound with the help of IoT platform. So thank you very much, sir. Thank you, sir.
Thank you. Thank you.
So if anyone is having any questions, so one can discuss with the sir. You have 2 minutes. If you have any query or any question, so you can discuss with sir. Okay, sir. So you can just exit from the meeting. If there will be any questions, so I will definitely mail you, and then the query can be solved after on.
Okay, thank you.
Thank you. Thank you very much, sir. Thank you. So all the participants, as we have now come to an end of the third day of this FDP on Internet of Things, and we have completed almost 9 sessions on IoT. So I hope you get an idea about how to work in the field of Internet of Things. And definitely we have some more sessions on IoT on tomorrow's as well as day after tomorrow. So I hope you are getting some knowledge from this FDP. So a little bit it will inculcate your knowledge in the field of IoT. So you can get motivated with this FDP uh, to work in the field of Internet of Things. So I hope you are getting benefited from this FDP. So thank you very much, dear participants. Also, there is one Google link has been shared to you through your email as well as on WhatsApp group regarding feedback of today's all three sessions that are session 7, 8 and 9. So you just have to make sure that you have to fill that form either through your WhatsApp or through your email. So you just have to fill that form. It will help us to get the feedback of individual sessions as well as it will helpful for us to keep in the record of your attendance also. So I request you to kindly fill that form in all respect. So thank you very much. Have a good day. Thank you. Bye bye. Yeah, I will definitely share you all the PPTs. I have already request to all the experts that kindly share their PPTs. So as I get all the PPTs, I will simply put all those PPT in a Google Drive and I will share the Google Drive link to your email as well as on WhatsApp group. And also I have decided to share all the video presentations also. So I have made a folder in the Google Drive. So as the lectures, all lectures completed, so I will put all the video sessions of those lectures on the Google Drive and the link I will just definitely share to you. So don't worry about that. You will get all the PPTs. Okay, so thank you very much. Thank you.